The problem I like to start out with, as far as Newton's first law of motion goes, deals with a box or some sort of mass, okay, hanging from some strings. And in this case, we have two strings, one attached to the ceiling and one attached to a wall. We have a mass hanging down, and let's just give it a value of 100 newtons. Remember, it's negative because it's pointing down. Now we actually have 3 ropes here. This third rope, or what I consider the third rope, I like to ignore. Okay, so I act like it's not even there. Now the other 2 ropes, there's actually some tension. All right, and as described before in class, if I have a single rope with a weight hanging down, the tension is pointing away from the mass. And so that's kind of similar to what we have going on here. Okay. I like to call this T1 for tension 1, and I like to call this T2 for tension 2. Now if you were to pick up a mass, attach a couple strings to it, and set this up, you can tell that you would actually be pulling up and to the left for T1 and over to the right for T2. Okay? So the goal of this problem here is to solve for T1 and T2. One other thing that's going to have to be given to you in these problems is an angle. All right? So let's just give this an angle of 30 degrees. Okay. So this is our made up problem. 2 ropes that we care about, a weight hanging down, it's 100 newtons, and one of the ropes is at an angle of 30 degrees with respect to the horizontal. If you think about it, T2 also has an angle. It's just 0 degrees. Okay. Now this is the simplest one. In other problems that we did in class and other future problems, you could actually apply this to 2 ropes at 2 angles, both attached to the ceiling. Okay, so the first step I like to do is write down all the forces that we have. So I have T1, I have T2, and I have the weight. Okay, we're going to make a little table here. To solve for T1 and T2, I need the components of each vector. I need the x component, and of course I need the y component. Now I like to fill in all the ones that are easy first. Okay. So if we think about the weight is hanging straight down. There is no x component. Okay. The y component would then be negative 100 newtons. Okay. Now if we look at T2, is T2 pointing in the x direction? Absolutely. How much of it is pointing in the x direction? All of it. And I'm going to put the plus sign just to say that it's positive x. The y value, if you think about it, is actually 0. Okay, it's pointing straight down. I'm trying to change color, but my marker's not, or my remote here is not working. There we go. Okay, so let's look at T1. T1 actually has 2 components that make up T1. I like to call those T1y and T1x. Okay. That gives us the nice right angle. Okay, and this is very similar to like what we do with projectile problems and that sort of thing. Okay, I'm going to draw T1 off here to the right so we get a better look at it. T1, T1y, T1x. My angle's 30 degrees. Okay, I need the components, t1y and t1x. Let's first do the x component. If I take the cosine of 30, I will get the adjacent t1x over the hypotenuse, which is t1. If I solve for t1x, I will have t1 cosine of 30. Now you may be asking, well, this is kind of odd because don't I want to solve for t1? Yes, you do, but you'll see what's going to happen here, okay? The fact is we have two unknowns, so we need two equations. So I'm going to write that in here. t1 cosine of 30 degrees. Is that a positive value or a negative value? It's pointing in a negative direction, okay? So it's going to be negative t1 cosine 30. All right, let's look at the y component now. We can do the same type of stuff we did for the x, but let's not, okay? If cosine goes with the x, then sine must go with the y. So t1 sine of 30 degrees. And that's actually positive because it's pointing up. All right, we have a nice table here. Now we need to think about Newton's first law. Newton's first law says sum of the forces equals 0. So what I need to do, I need to add up all of my x components and set them equal to 0. So sum of the forces in the x direction equal 0. All right? I'm going to add all these up right here and set them equal to 0. So I have negative t1 cosine of 30 plus, mistake there, plus t2 Alright, so plus t2 plus 0 equals 0. You may ask why I write plus 0 equals 0. Well, I want to make sure that you actually include this. Okay, so if you look at it later, you don't think that we set the first two equal to the weight. Alright. The second equation is sum of the forces in the y direction. So that would be plus t1 sine of 30 degrees plus 0 minus 100 newtons equals 0. Okay. Now if you take a look at this, we could actually solve for t1 right now by using this equation, Fy. Alright, so let's go ahead and solve for t1. I'm going to do my algebra. I take 100 to the other side. That would give me 100 newtons divided by sine of 30 degrees. If you punch that into your calculator, you should get 200 newtons. So that's one answer, T1. All right. Now, we could actually solve for T2 because since we have T1, we could plug it back into the sum of the forces in the x direction. I'm going to change some color here. Okay. So let's plug 200 everywhere we see T1. So we have negative 200 newtons cosine of 30 plus T2 plus 0 equals 0. That's from our first equation. I'm going to get a little room here. Now solve for T2. T2 is going to be equal to positive 200 newtons cosine of 30 degrees I punch that into my calculator and I get 173 newtons. Okay, that's the end of the first example problem here for Newton's law, first law of motion. It is the simplest string problem, if you ask me, besides having just one string. And if you notice here, we don't have any sign on T1 and T2. Okay, they are vectors. T2 we could probably put a plus sign because it's pointing directly in the x direction. But for T1, we have an angle of 30 degrees. Okay, now you can go ahead and write that by like T1 if you would like 200 newtons, negative 30 degrees or positive 30 degrees, however you want to write it. But that's totally up to you. We're just looking for the tensions. We can just write down the actual magnitudes, and that's okay with me. All right, so that's the first example.